Okay, so we are now at the final topic for lesson 2. We're going to talk now about what happens if you get an equation that is a linear equation. It's graphable, but it's not in the correct form. Now, the form that we're looking for is the y equals mx plus b form, because when it's in that form, we're able to easily distinguish what the y-intercept is and what the slope of that equation is. If you're not sure what I would mean when I'm saying that, then take a look at these 4 examples that are a bit troublesome looking. So we have 3y minus 12x equals 15. We have y plus x equals 3. We have 4y minus 2x equals negative 8, and we have y plus 3/4 x minus 5 equals 0. So if you take a minute to look at that and then compare, or look at those 4 and then compare them to what's in the little black rectangle at the top, y equals mx plus b, I think you'll notice that we have a bit of a problem here. We need the y equals mx plus b form to be able to graph, and none of these 4 examples are in that form. So what do we do? The answer to that question is actually something that we discussed in the first unit, which is how to rearrange equations and solve for particular variables. So, in the y equals mx plus b equation, we have solved for y in a sense. And what I mean by that is that we have y equals and then all the other stuff. So y is on the left, equals sign, and then all the other stuff is on the right. So that's what we're trying to get to happen. So in other words, over here at 3y minus 12x equals 15, we want it to eventually say y equals blah, 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 whatever the blah, blah, blah happens to be. That's what we want to get done over here. So let's think about how we would do that. We're trying to isolate y, get y by itself, so we look for the things that we can move first. Now we want to kind of unpack it from the outside down into the inside. So the thing we want to move first is the negative 12x. We want to move this entire term. If we want to move the entire term, we need to either add or subtract. Since it's a negative 12x, I will add 12x to both sides. Now, if at any point you're forgetting how to rearrange equations, you can always go look back at those videos to get some more details. But I'm going to assume that we all remember. So to get rid of the 12x, we're going to add 12x to both sides. So that gives me 3y equals 12x plus 15. Now I could have written this as 15 plus 12x, right? It doesn't really matter which order. I like it with the x on the left because it looks a lot closer to where I'm trying to get, the y equals mx plus b. So 3y equals 12x plus 15. Is the y by itself yet? No. What is the problem still? Well, we have this 3 hanging out over here. Now, we don't want to move the whole term. We don't want to just move 3y. We just want to get rid of the 3. Y is fine. We want to get rid of the 3. 3 is multiplying y. It's a coefficient of y. So how do I get rid of something that's being multiplied? I divide. So I'm going to take this side of the equation and divide it by 3. And I'm going to take the right side of the equation and divide it by 3. Now here is where I see, again, this is a hint, somewhere that I see errors happen frequently, is instead of dividing both sides entirely by 3, a student might just divide 12x by 3 and leave the 15 alone. And you might ask, well, why does it matter? Why can't I just divide? I'm only dividing one term on the left. Why do I have to divide both of them on the right? Well, it's that idea of the scale again. Remember, we talked about an equation is kind of like a scale. So if we're going to divide the left side of the scale 3 times, we have to divide everything on the right side by 3. And it kind of works like the distributive property. 12x is divided by 3 and becomes 4x. 15 is divided by 3 and becomes 5. And then over on the left, we just have a y left over, which is what we were hoping to have. Oops. So y equals 4x plus 5. How did I do that? Again, I moved the 12x term, and then I divided both sides by 3, and here I have an equation in the form of y equals mx plus b. So what would m be? Well, m would be the 4, right? The coefficient of x, so the slope here is 4. And the b, or the y-intercept, would be the plus 5. So it would have an intercept. It would touch the y-axis at 5. Okay, so that's example 1. Let's apply the same idea over here to y plus x equals 3. This one actually is probably a little bit easier than our first example. We only have one major problem that's keeping this from looking like y equals mx plus b, and it's the fact that y and x are on the same side. So let's take the plus x and move it to the other side. How do I do that? I subtract x from both sides because I want to move the whole term, so I subtract the whole term. That leaves me with y on the left, and it leaves me with negative x plus 3. That negative sticks with the x because I subtracted the x. Now you might ask, why did I not write it as 3 minus x? Well, I could have actually. 3 minus x is the same thing as negative x plus 3. So whether I write it as this or as that, I get the same answer. However, look back at our model, y equals mx plus b. In the mx plus b model, the x term comes first, and that's why I've written it first in my example. So we will not say 3 minus x, we'll say negative x plus 3. And just like that, we are done. So what would the y-intercept be in this case? It would just be plus 3. That would be the b. And what would the slope be? Well, it looks kind of like we have no number out here, but for those of you who are quick on the draw, you're probably hopefully saying, yes, this is really just negative 1. There is a number here, negative 1x. And so the slope in this case would be negative 1. And what is that as a fraction? Well, we would just think of it as negative 1 over positive 1, right? That would be negative 1. So rise would be negative 1, or it would fall 1, and the run would be 1. So rise over run would be negative 1 over 1. And the b term would be 3. Okay, moving on to the next example. Okay, 4y minus 2x equals negative 8. Sort of similar to what we had in our first example. We have a negative, we have a negative x term that we need to move to the other side. So to start out, we're going to add 2x to both sides. That's going to leave us with just 4y on the left, and it's going to leave us with 2x minus 8 on the right. We try to see if we're ready or if we're done. No, we're not, because there's still a 4 in front of the y. How do I get rid of the 4? Well, I just divide it away. Divide by 4. If I'm going to divide the left by 4, I have to divide the whole right side by 4. Which means, so I'm going to end up with y equals over here, which is good. That's what we wanted. Whoa, I'm like running out of room. Y equals. The question is, what do I end up on the right side? Well, let's take one term at a time, because remember, when we divide the whole side, it has kind of a distributive effect. I'm going to divide 2x by 4, and I'm also going to divide negative 8 by 4. So 2x divided by 4 is going to give me a fraction. It's going to give me the fraction of 2/4 x. Now, if you're like me, you're going to look at the 2/4 and say, wait a minute, 2/4 can be reduced. Why say 2/4 if I can really just say 1/2, right? Because I can reduce 2 over 4 to be just 1 over 2. And I hope you would agree with me. I'm going to change that, and instead of 2 over 4, I will just write 1/2 x. How did I get that? Again, it's just the 2 divided by the 4. I'm multiplying x now by 2/4. And then minus 8, I want to divide that by 4, which becomes minus 2. And I have my y equals mx plus b equation, where the m is 1/2. That means the rise is 1, the run is 2, and my intercept is negative 2. All right, just for good measure, let's finish with our last example. In this case, I have everything over on the left side and nothing on the right side. So I need to move everything except the y over. So the y can stay, but the other terms need to be moved over. So I will subtract 3/4 x from both sides, which will give me y minus 5 equals negative 3/4 x. And then I can add 5 to both sides to get rid of that term, which will give me y equals negative 3/4 x plus 5. Which will give us a value for m of m equals negative 3/4, which would be a rise, or really it will sink, right, by negative 3 and a run of 4. And my b, or my intercept term, will just be positive 5. Okay, I'm starting to move a little bit more quickly through these examples because I'm hoping that you're starting to catch on more and more, and that all of this information is coming back to you. However, remember, this is a video, so if for some reason you think I've moved too fast, go back, pause the video, take a look at what I've written, and take as much time as you need. And that should finish us up for lesson 2, and we'll come back tomorrow to talk a little bit more about ways that we can create equations using this idea of slope and y-intercept. But what happens if we get some kind of crazier information? Like, what if somebody just gives me 2 points, like 2 points on the line? Can I create an equation from that? Or what if they tell me what the slope is and they give me 1 random point? Is that enough information? We're going to find that out tomorrow. But for now, you are good to go.